Okay, so second half of our video here, I'm going to try and do as many of these as I can in a reasonable time. I don't want to do a 45-minute video for this review, but solve each equation. So these are obviously equations with fractions, so we need to practice eliminating fractions. There's a couple different strategies you could use, but what will work every time is multiplying by the lowest common denominator all the way through our equation, and that'll ultimately eliminate the fraction. So right over here, our lowest common denominator, 7, 7, and 1, is a 7. Right over here, our lowest common denominator, 3, 4, and 1, is a 12. Right here, our lowest common denominator is 1, 1, 3, 2, 1, is a 6. And here, my lowest common denominator, 2, 1, 6, 1, is 6. So first I need to find what the lowest common denominator is, or any common denominator will work, and then I'm going to multiply it all the way through. All right, so I might start all of these problems, but not finish them all because it would take quite a bit of time, but we should be able to solve them once we get rid of the fractions. So here on part A, I'm going to distribute the 7, and I'm going to end up with 7 times 3 is 21x over 7. There's also not a lot of room here. Plus 7 times 2 is 14 over 7, right? Remember when we multiply, we only multiply the tops. Equals 7 times 2 is 14 over 1. Right, so if I picked a good number, then these fractions should reduce. So here, 21 divided by 7 is 3. So 3x plus 14 divided by 7 is 2. 14 divided by 1 is 14. 3x plus 2 is 14. So right, subtract 2 from both sides. 3x is 12, and the x is 4. I'm actually going to pick a different color here. So now I'm going to multiply a 6 all the way through. Every single term. So 6 times x gives me 6x, plus 6 times 3 is 18, right? I could keep it over 1. 6 times 1 is 6 over 3x. 6 times 3 is 18 over 2x. 6 times 6 is 36. So all I did was multiply every term in that equation by 6. And now the equations, or the fractions, should drop out. So 6 divided by 1 is 6x. 18 divided by 1 is 18. 6 divided by 3 is 2. 18 divided by 2 is 9. 36 divided by 1. So now I have an equation with no fractions. All right, so I can combine like terms. And I need to keep going, but I'm going to, for the sake of time, kind of leave it there. We should be able to solve that at this point. And then one more. I'll do D because it looks a little bit harder. So my common denominator was 6, and I'm going to multiply that all the way through. So 6 over 2x plus 48 over 1. 6 times 5 is 30 over 6x equals 6 times 4 is 24 over 1. So just multiply every single number on the top by 6. And now these will divide out, right? 3x plus 48 plus 30 divided by 6 is 5. X equals 24. So 8x plus 48 is 24. If I subtract 48 from both sides, 8x is negative 24, x is negative 3. So we'll work that one all the way to the end. All right, so here's 4 problems. 4 problems. We'll see. I'm going to just pick, they're all basically the same type of problem. So I'm going to pick a different color, but I'm going to pick this one here, F. Okay, so when we solve these, we can only do these with common bases. So 16 and 64 are not the same. They're not the same number. So I got to rewrite them with a base that's the same. So I know 16 is 4 squared. So I'm going to write my 16 as 4 squared. There's 16. So that's 16 to the 4x. And 64, I'm going to write as 4. 4 times 4 is 16. Times another 4 is 64. So that's 3 4s. So there's 64 right there. 4 to the third power. So that's 64 to the 2x plus 4. So now we're getting somewhere because we have the same base. But now I have to apply exponent rules. So I have a power to a power on both sides. When I have a power to a power, I multiply them. Right? I have to multiply them. So I'm going to end up with 4, and I multiply the exponents. 2 times 4x. And over here I have 4 times 3 times 2x plus 4. Right, so now I have, I'm going to bring this up here. 2 times 4x is 8x. And over here, if I distribute that through, I get 6x plus 12. So now I have the same base, 2x, 4 and 4. So the equation tells me, obviously, the equation means equal, so they're equal to each other. So if the sides are equal, the bases are the same, that means that the exponents are the same. So that means 8x has to be the same or equal to 6x plus 12. Subtract 6x from both sides, and 2x is 12. The x must be 6. Alright, so these other ones, E, G, and H, are all going to be pretty much the same. Right, so this would be 3 squared to the 2x minus 1. Right, so you'd end up with 3 to the 4x minus 2 equals 3 to the 6. So 4x minus 2 equals 6. Right, so just to kind of set these up for you, this would be 6 to the 7 minus x. 36 is 6 squared to the 2x minus 4. So right, so that's kind of how those would be set up, and you'd have to, over here, you'd have to distribute and then solve. Okay, so I don't want to take tons and tons of time redoing the same type of thing. All right, so number 8, given the graph on the right, write the following equations. The equation of the line that goes through A and B. Okay, so point A is 6, 9, and point B is -6, -1. So I'm going to find the change in y. So from 9 to -1 goes down 10. And I'm going to find the change in x. So from 6 to -6 goes down 12. And my slope is change in y over change in x. Right, the negatives cancel. So 5 over 6. My slope is 5 over 6. So now, y equals mx plus b. I just found what the m is, so I'm going to replace the m with 5, 6. And I can use either one of these points, so I'm going to pick point A because it's got all positives, and I like that. So I know for A, the x is 6, and I know for A, the y is 9. So I plug those in. Now I'm just missing the b, and that's what I need to complete my equation. So 9 equals 5 times 6 is 30, divided by 6 is 5, right? Or I could have canceled these out, plus b. So subtract 5 from both sides. Well, subtract 5 from both sides, I get a 4 equals b. So the b is 4. So I know the m, and I know the b. So my equation would be, kind of ran out of space here, but y equals 5/6 x plus 4. Once I found the slope, right, 5/6, I could go up 5, 1, 2, 3, 4, 5, and over 6. All right, go up 5/6, and I would see right there is the y-intercept at 4. Okay, the equation of a line that goes through A with the same slope as line K. So down here is line K. Same slope as line K. So the slope for line K is 2/3. So it goes through A. So A, I know, is 6, 9, right? That's x and y. So it's giving me an x, a y, and an m. So I got to solve for the b. Right, so y equals m x plus b. So 9 equals 2 times 6 is 12. 12 divided by 3 is 4. Right, so 4 plus b equals 9. I know the b has to be 5. Right, so y equals 2/3 x plus 5. And line perpendicular to line K. So remember, line K, the slope was 2/3. So perpendicular, the slope's going to be opposite reciprocal. So my new line will have a slope, instead of positive 2/3, it's going to be negative 3/2. And point B is -6, -1. So same idea. I know I have an equation, y equals mx plus b. I know an m, I know an x, and I know a y, so I can plug them in. So y equals m x plus b. I'm going to solve for b. So -1 equals, negative times negative is positive, so I can forget about the sign now. 3 times 6 is 18, divided by 2 is 9, plus b. Subtract 9 from both sides, you get the b by itself, -10. So y equals -3/2, that's the slope, x minus 10. And think about that, that would be like, it would come through here and go down here. All right, last problem, it's a whole page, but it's really not that long. Kelly works at Pelicans on the weekend. She notices sales of shaved ice seem to vary widely from day to day. This is a problem because preparing too much shaved ice results in a waste, and making too few results in lost sales. She decides that the daily weather may have a strong association, so she chooses 12 days at random and see how much is sold each day. So basically, how much shaved ice is sold on a day, versus the temperature. And then she plotted those points. So let's see what we got here. So using the 2 points that she's identified specifically fall on the line, A and B, calculate the slope and the y-intercept, right? So slope, point A is 80 and 131, and point B is 44 and 77. So to find the slope, right, I need the change in y, and I got to divide that by the change in x. So 131 to 71 goes down 54, and from 80 to 44 goes down 36. So my slope, change in y over change in x, -54 over -36. If I divide that out, the negatives cancel, and I get 3 over 2. I'm going to make it a decimal just because that's probably what most of you will get in the calculator. So 1.5. So what does that mean? So show calculations for the slope and the y-intercept. Well, that's my slope. I don't really know that you need to show calculations for the, to find the y-intercept. You could plug that slope and, like one of the ordered pairs into the equation and solve for b like we did on the last 2 problems. What I would do is just look right here. There's the y-intercept. So the y-intercept is 10 and the slope is 1.5. What does that mean in this problem? So the slope is 1.5, so it's increasing 1.5 cups for every degree. Increase 1.5 cups every degree of temperature, and that's the slope. And the y-intercept, means I would expect 10 cups at 0 degrees. I don't know who's buying shaved ice when it's 0 degrees outside, but I guess 10 people do. All right, using the line of best fit, predict the number of cups with the temperatures the following. So when the temperature's 30, so all I got to do is go over to 30, and I'm going to go up and see where it hits. It hits right there. That's about 55. At 56, so I'm going to go somewhere in here. Go straight up. Whoops, well, I kind of messed that up. But it's going to go up to about here. So like 97 maybe, and so on. All right, so you can do it from there. You could also use the equation. All right, so 1.5x plus 10. Let's try it for this one. All right, well, if the x is 100, I would expect 2 zeros, 150 plus 10, 160. So let's see, when it's 100 degrees, oh, it didn't quite fit on the thing, so it's going to be somewhere, yeah, that's about right. It would be somewhere up here, which would be right, around 160. So you can use the graph or you can use the equation. Right, and the domain and range, so domain is the x and range is the y. So if I look, where did it operate? My graph was pretty good between about 30 degrees and 90 degrees, and between about 50 and 150 cups. So my domain was like 30 to 90 degrees, and my range was like 50 to 150 cups. So the way I would want to write that is like this. Something like that. So this was kind of a quick video because my original video died, no sound after I got to the end. So I'm kind of speeding through, but hopefully this will help a little bit.